Okay, so yeah, welcome everybody to our first remote meetup, virtual meetup. As you might know, we've joined forces, the Kubernetes and the Docker meetup. Adele organizes the Docker meetup, and Pavel and me, we kind of organize the Kubernetes meetups. We've joined forces, and indeed, welcome everybody. The first trial, as said, we have to give thanks to the CNCF because they're actually sponsoring the Zoom video conferencing. And don't forget to subscribe to our Twitter and YouTube channel, where we're going to post the recordings of what we've done. Yeah. And logistics and the agenda, please keep the mic muted. Most of you are already professional enough to do that during the time when there are talks. But if you have a question, as Adele asked, just barge in and ask the question directly. I guess unless any of the speakers says they want to have questions at the end of the at the end of the session, but I just heard you're okay with that, right? And well, we're still looking for speakers for our next meetup. So if you have any interesting content, please yeah, come up to us and send us a note. We're really looking forward to hear from other interesting stuff. And with that, first of all, thank you to our speakers. That's Torin and Nico, who have graciously spending their time to share with us and talk about what they're doing. And indeed, our first talk is by Torin about the open policy agent. I think you have read the abstract. I just want to point to something interesting happening today. So today there's the TOC is meeting as well of the CNCF, and there's a call to action to review the proposal to make open policy agent enter the CNCF sandbox stage. Is that right, Torin? That actually
that's right. Yeah. Yep.
Call went out today, so very excited. And with that, let me hand it off to Torin. Yeah, can you?
Great, perfect. Let me share my screen here. I've got some slides that I'm going to put up.
My share.
Okay, perfect. Let me just make sure that I can still see the chat. So I'm just trying to make sure I can still see the chat. Okay, great. Perfect. So everybody can see my slides. They're visible?
Yes, they are.
Okay, perfect. Okay, so yeah, thanks to Vasu and Adele for setting this up. We love talking about the Open Policy Agent project. And so anybody that wants to hear about policy, we love chatting with them. So what I'm going to do today is talk a little bit about the project. And to get into that, I'm going to go through a little bit of background about what we mean when we're talking about policy. And then I'll dive into the project itself. I'll talk a little bit about the community and the integrations and sort of how it works. And then I'm going to do a little deep dive into how you can use the policy agent with projects like Kubernetes. And then I'll have a demo, and we can also do Q&A at the end. But if you have questions as I go through the content, feel free to post them in the chat, and I can reply. Okay, so when we're talking about policy, basically we're talking about these rules that are intended to govern how the system should behave. And so these are things like where a workload needs to be placed, or whether or not to allow a request, or who can SSH into a machine, and so on. And the interesting thing about these policies is that they happen to affect basically every company on the planet, and they're also vital to the long-term success of those companies, because they codify important requirements around things like cost and performance and legal regulation and internal convention and so on. Now, the other interesting thing about these policies is that they're often quite difficult to enforce. And the reason for that is that they tend to be organization specific, meaning every company has a slightly different technology stack, or they want to enforce policy slightly differently, and so on. And then moreover, they're typically applicable across the stack. And so you'll find policies that need to be applied in your orchestrator and at the host level and in the network and so on and so forth. And so you have these policies that are often difficult to predict in advance, that evolve over time, that are technology specific and organization specific, and so on. And so, it's not surprising then that the way that companies enforce policies tends to vary quite a bit. And so what we see is kind of on the one end of the spectrum, you have companies that just kind of fall back to things like tribal knowledge and wikis and spreadsheets to hope that the system is running the way it's supposed to, right? And so the way that typically works is that if you have to enforce a policy or get a policy decision, you go and ask somebody on the team that's responsible for that system, right? And like Bob knows how to set the configuration just right, and things just kind of work and they're secure and whatever. The problem with that obviously is that you don't get very strong guarantees, and you don't really know that the system's actually doing what you expect it to. On the other end of the spectrum, a lot of companies start by hard coding policy enforcement into their systems. And so while that gives you a stronger guarantee that policies are being enforced the way you want them to, the problem is that they become very expensive to change and also to understand, right? Because you have these policies, these decisions that are now deeply embedded or intertwined with the rest of the application or the rest of the system. And so what you need is like someone that's an expert in that system, in that software, in order to make changes and also to just understand what rules are actually being enforced. And so over time, there have been other projects that have, and solutions that have popped up in this space to help you do policy enforcement. But the problem with a lot of these policy engines and these policy enforcement solutions today is that they don't let you say the things that you want to say in your system. And so a lot of the time that they're domain specific, meaning like they apply to the network, or they apply to SSH access or something like that. You can't take them and reuse them outside of that domain. Or they don't let you even say the things that you want to say within that particular domain, right? So you can't even express the logic that you need in order to enforce the policy. A lot of the time you can't access things like context in order to make decisions. And the decisions that you want to make, you can't even express them, right? They're limited to things like true or false or allow, deny kind of decisions. And so they're very kind of restricted. Moreover, a lot of the time you can't even compose them. So you can't take some policy that someone in the network team created and a policy from the security team or the compliance team and combine them in order to enforce policy holistically across the stack. And so this is the problem that we sort of set out to solve with the Open Policy Agent. So OPA is an open source general purpose policy engine. And what that means is that you can basically take it and use it to enforce policy anywhere, in any system, at any layer. And so the way that it does that is it gives you this sort of building block that you can use to offload policy decisions from your services. So the way you think about this is that when your service needs to make a policy decision, like for example, whether or not to allow a request, it offloads that decision by querying OPA for an authorization decision or for a policy decision, right? Like whether or not that request should be allowed or denied. And then OPA takes that policy or rather takes that query, and it evaluates all the policy and the data that it has access to in order to produce a decision that it can return to your service. And so by doing this,
Torin, can I ask a question
go ahead,
right here? Because maybe you'll allude to that later on. But I'm just wondering. You're saying it's you need to have policy requirements across the stack, right? So I might have OpenStack, I might have VMware, a storage system or whatnot. That's my service. So the generic thing is, do I always need to have a service proxy in front of that where you can link in the OPA, or how do you go about that?
That's a good question. So I'm going to get into integration, and I'll show how that's actually done in a minute. But just for now, just think of it as a service, right? So this could be like an orchestrator like Kubernetes, or it could be your application, or it could be something in your CI/CD pipeline or whatever. It's sort of just meant to be just to think of it as you have some place where you want to enforce policy, and you do so by offloading that policy decision to OPA, and that's all that's sort of that's what you need to keep in your mind right now. Okay. So what OPA gives you to do this, and the core thing that OPA provides, is this high-level declarative language. And the language exists so that you can codify policies. So when you use OPA, you're writing these rules that answer questions like, is this user allowed to perform this operation on this resource? Or which hosts can a user SSH into? And so on. Now, the interesting thing about the policy language is it's not just specific to allow, deny decisions. So you can, if you want to generate, like the set of clusters where a workload should be deployed, the language empowers you to do that, and it's sort of designed to allow you to enforce all these different kinds of policies at different points in the system. And I'm going to get into some examples of what that looks like in a minute. So when you take OPA and you use it, you kind of have two options. You can either use it as a library if your application is written in Go, or you can use it as a daemon. And when you use it as a daemon, you access its functionality through HTTP APIs. Now, OPA itself is designed to be as lightweight as possible. And so what that means practically is that all of the data and policy that OPA uses to make decisions, all of that stuff is stored in memory. So OPA doesn't introduce any kind of runtime dependencies on like a coordination service or a database or a storage layer or anything like that. Everything is just kept in memory. And the benefit of doing that is that not only does it help with policy evaluation and latency, but it also ensures that since OPA is running right next to your service, it's going to be available basically for answering policy queries because it's not running across the network and subject to network partitions. So OPA, you can think of it as this sort of building block or this library that you use to offload decisions to. And in order to do that, what OPA gives you is this core set of functionality, which is a parser and a compiler and an interpreter that you can use to ask policy questions of. Now, in addition to the core kind of evaluation engine, OPA also provides a bunch of tooling like a REPL, read eval print loop, and a test framework and debugging infrastructure and so on to help you kind of build and test and debug your policies as you create them. And then finally, sort of in addition to the core project, we also have a suite of integrations and a growing standard library of policies that you can take and use to enforce all kinds of things like access control and admission control and auditing across projects like Kubernetes and Istio and Terraform and so on. And so the nice thing there is that if you want to get up and running quickly without necessarily integrating with OPA, you can do that because there are integrations that exist with these popular projects. And there are also existing policies that you can take and use or modify for your own purposes. So I'm going to get into the details of OPA in a minute, but I just wanted to talk a little bit about the community and how the project sort of came to form. So we started the project back in early 2016, and the initial release we did back in the summer of 2016. So about a year and a half ago, we set out to build the Open Policy Agent. And the goal there was really to create this new policy engine that you could use in different projects at different layers of the stack, and that could produce policy decisions that weren't just coupled to things like allow or deny. And so we did that, we built that initial kind of feature set, and then we took it and we started applying it to all kinds of different applications like authorization and mission control and placement and so on. And so lately what we've been doing is taking it and solving like real problems out in the community and in the space, but then also focusing on kind of hardening it and optimizing it and making sure that it's a reliable building block that you can take and use to enforce different kinds of policies up and down your stack. And then I'll also call out that earlier last year rather, Google or Firebase came on board as design partners. And so as of like the late spring of 2017, we've been working closely with Firebase on some improvements to the language and a bunch of integrations as well. Now, in terms of adoption, there are a bunch of companies using OPA today. This is sort of just a snapshot of them. But like one main company that's using it is Netflix. And so what Netflix does with OPA is they use it to enforce different authorization policies across their stack. So for example, they use it to control who can do what in their HTTP and gRPC APIs in their microservices. They use it to control who can connect to Kafka and push messages into their pub subsystem. They're looking at other use cases like SSH access control and so on. And so the cool thing there is that it's being used for this variety of different authorization and access control enforcement. But it's also being used by multiple teams across the stack, which is really what it was designed for from the beginning.
So one of the interesting thing which stands out is like Kafka. Kafka, I think, still is working on authorization and all of these facilities internally. So you can layer on top authorization models, and the original product does not need to even support that. Is that what I'm hearing?
Yeah, most of the time these projects support some kind of plugin model, and so they allow you to kind of they sort of decouple the security of the authorization decisions from the core of the projects. And so Kafka has like a plugin model that allows you to call out and get an authorization decision from an external system. And so that works with OPA, but it also works with other systems, right? So that's one of the ways that you can kind of take OPA and use it or integrate it with existing projects, right? Is through these plugin models. And I'll talk a little bit more about the API that OPA exposes in a minute, and I'll show how it's designed to be as simple as possible to make it easy to build these integrations, because that's one of the important things, right? Like, it's nice to have this project on its own that you can, write policies for, but at some point, you need to integrate it, and so the API is designed to be as simple as possible to facilitate that. So another company that's using OPA is Medallia, and so what they're doing is using OPA sort of for a risk management use case where they want to perform authorization checks over changes that a tool like Terraform would make against AWS. And so, for example, if you have a large AWS deployment that you're managing with Terraform, you may want to be careful about who can do what or who can make certain changes, right? So you might want to give a budget, for example, to a junior engineer that restricts them from deleting 5,000 instances or something like that, right? Whereas a senior engineer, a senior operations engineer would be allowed to make those changes. And so that's what they're using OPA to help enforce in their system. Huawei is another company, a big company that's using OPA, and they've got a number of use cases around Kubernetes to do with things like placement and storage selection and authorization and admission control and so on. And I'm gonna dive into that use case a little. Some of those use cases a little bit more in a minute. So I've mentioned some of the companies that are using it. This is just a snapshot of the different integrations that we have for OPA today. So a big use case for OPA is within Kubernetes around admission control. And I'm going to talk more about that in a minute. But the idea there is that you have resources being created in your cluster, and you want to enforce certain policies over the types of resources or the attributes of the resources that are created. And so, for example, if you want to control what clusters a sensitive workload is deployed to, an admission controller that uses OPA is a great solution for that. Or if you want to restrict, where images are allowed to come from, perhaps in a specific namespace like the production namespace, OPA is a great fit for expressing those kinds of rules. Another popular application for OPA is around API authorization. And so we've seen OPA integrated into projects like Istio and Linkerd, and we have support for Cloud Foundry to enable sort of API authorization at the microservice layer. And so what OPA gives you there is this nice fine-grained policy language to enforce different kinds of access controls or who can do what in your microservices. So for example, if you want to restrict test scripts or something like that from accessing production services, it's really easy to codify that logic with OPA and have it enforced automatically. Or if you want to restrict the access that like certain people in your organization have to APIs that's serving sensitive data, OPA gives you this nice framework to do that. We've also taken OPA and used it sort of at the host level. So we've integrated it with Docker to do kind of authorization or admission control checks against container execution. And so if you want to restrict, what access the container has to the host or what kind of, security profiles it can run with, OPA gives you this good framework for doing that. And we've also built, integrations for things like PAM, which allow you to control who can like SSH into a machine or who can run sudo commands and so on. And then sort of at the infrastructure provisioning layer, like I just mentioned, companies like Medallia are using OPA for risk management, where they want to control, the sort of blast radius that a particular change set can have on their infrastructure. So what I want to do now is talk a little bit about how OPA actually works and how it actually satisfies all of these use cases. And so the important thing to keep in mind here is that OPA isn't coupled to any particular domain or layer of the stack, okay? So when you're thinking about OPA, you're basically thinking about policies and data, and then services querying OPA to get back policy decisions. So the idea is that whenever a service needs a policy decision, like when it receives a request or some event happens, it executes a query against OPA. OPA takes all the policy and the data that it has access to, and it evaluates all of that before returning a decision back to the service, so that the service can go off and enforce it. So to sort of walk through this more concretely, let's take this example policy and this example system. So say we have a service that's providing salary data to the organization. And so you can ask the service, what's the salary for a particular user or a particular employee. The way this would work is that when the salary service receives a request, like get on /salary, it would execute a query against OPA, and it would ask for a decision back, basically. And OPA would, like I said, take the policy and the data and compute a decision like true or false or allowed an I, which would then send back to the service. Now, the important thing to keep in mind here is just that the decisions in OPA are named, and they can be organized hierarchically. And so here we've chosen to kind of namespace the authorization decision under /http/authorization/allow. And so when the service wants to get an authorization decision from OPA for its API, it would query OPA using that name or that path. And so what we're going to do is show how you can take this example policy, which just says that users are allowed to read their own salary and the salary of anybody who reports to them, and show how you would take that and enforce it using OPA. So the way this works today is that you have a salary service, right? And it's exposing some API. And whenever it receives a request for that API, it executes a query against OPA. Now, when it does that, what it provides is a bunch of input data that describes the API request. And so on the left, you can see like an example of what that data might look like. So for example, the salary service provides the method from the incoming request, the path from the incoming request, which we've represented as an array here, and I'll explain that in a minute. And then also like the user making the request. And so the important thing to notice here is just that user is sort of the authenticated user, okay? So OPA is not trying to perform any kind of authentication. What it's allowing you to do is offload the authorization decision, or the decision about whether or not Bob is allowed to do something. It's not trying to authenticate that Bob is who Bob says he is. So the way this would work is that the salary service would execute a query against OPA, and OPA would take the input from that query and use it to evaluate the policy that it has to grant access to the API. And so on the right, I've got an example of a rule that would do this. So the way you can basically read this rule is as follows. So allow is true if input.method matches get, and input.path matches salary user, and input.user matches user. Now, the interesting thing here is that user value is actually a variable. And so what's going to happen is that when this rule gets evaluated, the user variable is going to be bound to a value from the input. And it's going to have the same value in all of the expressions in the rule. And so in that second expression, it's going to first get bound to Bob. And then in the second expression, it's going to act as like an equality check. So we're going to, in this case, bind it to Bob in the second expression. And then in the third expression, we're going to check whether input user equals Bob. And so in this case, because Bob is requesting his own salary, the request would be allowed. And so that value of true would be sent back to the salary service, and the request would go through. So that deals with the first part of the policy, which is allowing users to read their own salary. But what we also want to do is allow anybody, to allow anybody who reports to someone allow managers to see basically the salary of anybody who reports to them. And so to do that, we need a little bit of extra data or context in order to make the decision. And so what we would do is add another rule, which looks very similar to the first one, that's basically going to check whether or not someone reports to them. And so in this case, we have the same rule, which you can read again, is just allow is true if the input method matches get, and then the path matches salary user. But now instead of checking whether the input user is the same as the salary or the salary user, we're going to check whether the input user is a manager of that salary user. And so the interesting thing here is that this last expression depends on data that's just been pushed into OPA. And so you can see on the left an example of that kind of data where we map the employee or the user to their manager. And so in this case, if Alice is requesting the salary of Bob, the request would be allowed because the data indicates that Alice is the manager of Bob. Okay, so this just walks through a simple example of how you codify these kinds of policies with OPA, and I'm going to get into more detail in a minute with a demo of this. So the interesting thing here, though, is basically that OPA is not coupled to any particular domain or data model or anything like that, right? And so whether you're trying to enforce policy over an HTTP API where you're looking at the method and the path and so on, or SSH where you care about the host and the user logging in, or Kafka where you care about the service pushing to the topic or the name of the topic and so on, it's all the same to OPA. It's all just data. And these policies are basically just logic that you express over the data. The powerful thing about OPA is that it gives you this purpose-built language for expressing these kind of authorization decisions or these policies over arbitrary data. And so this is why we can say that OPA is sort of a general purpose policy engine that you can take and use at any layer in your stack. Okay,
so one question directly from the use case about the manager of, right? I mean, this exposes one of the issues that some of the policies we might need to adhere to involves querying data, vast amounts of data, which might not fit into a small memory footprint, right? Do you also have, can your policy engine also do queries outside and get the required data? Is that also
yeah,
possible?
absolutely. Yeah, so that's a good question. So like in the case where you have like a large data set that you can't replicate into OPA, there are different ways that you can kind of get around that. So, a really simple way of doing it is to have a call out in the policy that like executes an HTTP call against some service and gets back data that it uses to inform the policy decision. And that works in some cases. In other cases, you can actually rely on things like JOT tokens to kind of wrap up and encapsulate the information that you need in order to make the policy decision. And in that case, the policy decision is really just a function of the input, right? It doesn't depend on external context. But in a lot of cases, actually, the data that you need to make policy decisions over often does fit in memory. And so the nice thing about replicating it to OPA, like having a cache of it in OPA, is that then it's always available, and there's no latency or availability sacrifice that you make for having to call out over the network and so on.
Okay, so I think I mean if you do all these call outs, you also become a critical path in such call cases, right? So do you have these kinds of, I mean, from a design perspective, I see that it just makes sense to keep it simple and in memory, but do you have use cases where you actually do these kinds of call outs, and how do you consult or recommend to restrict these cases, or?
Yeah, I mean, I think you're better off caching the data inside of OPA if you can, right? Like keeping the decision local to the host is better if you can. And a lot of the time that comes down to how you distribute policies and data, right? So, when you start trying to build a system around this, you'll end up having to distribute policy and data, and that's something that you can kind of tune inside of your own system. Mm-hmm. But you have that escape hatch of calling out if you need to.
Okay.
Yeah. Okay, so the next thing I want to look at are some use cases where we've applied OPA. And the first one I want to get into is, sorry, my screen's locking up a bit here. The first one I want to get into is Kubernetes, because this is, after all, a Kubernetes and Docker meetup. And so we've taken OPA actually and applied it at a bunch of different places in Kubernetes. So you can actually use it today within Federation to do policy-based placement. We've shown how you can use it as an authorizer or a webhook authorizer in the API server. We've also shown how you can use it as a scheduler to decide what nodes your pod gets deployed to, and a bunch of other things like auditing and so on. But what I want to focus on right now is actually admission control, because that's a great fit for OPA. And so just for those that aren't totally familiar with it, admission control is this process that runs within the API server whenever you create an object within Kubernetes. And so the idea with admission control is it's sort of like the last point where you can enforce policy or checks or perform defaulting and so on before an object gets created in the cluster. So whenever you create a new object, or you update an object, or you try to delete an object, this sort of sequence of admission controllers run, and they make a decision about whether or not to allow, deny, or update the object before it gets persisted to the database. Now, the way that you can introduce OPA is in 1.9, there's this new support for validating webhooks and mutating webhooks. And so what you do there is you basically configure, you basically enable the webhook on the API server when you create Kubernetes. And then you take OPA and you can actually just deploy it on top of Kubernetes itself and have it register as an admission controller. And so then whenever a new object is created in Kubernetes, like when you run kubectl, create, or apply, and so on, this little call out happens from the API server to OPA to ask whether or not to allow or deny or modify the object. And so the nice thing about this is that then the entire sort of surface area of the Kubernetes sort of API, the Kubernetes objects, these manifests that you're working with all the time, it's now under the control of policy, right? You can write rules that control, different things about the objects you're creating. So for example, a lot of companies want to enforce policies that say that, all applications have to have a contact labeled on the resource when it's created, right? So that if there's an outage, or whatever, they can get in touch with the person that's responsible for it. Or, you might want to say that if this is a high criticality application, it needs to have some minimum number of replicas. Or you might want to enforce naming conventions on the pods, right? Or you might want to restrict which, repos the images can be pulled from, depending on the namespace you're running in, and so on and so forth, right? The interesting thing here is that these policies are very organization specific, and they're pretty much impossible to predict all in advance, right? So you can't take this logic and bake it into the API server as hard-coded, code, right? You need to be able to change this easily and flexibly on the fly. And so that's what OPA sort of exists to give you, is this fine-grained, flexible control over your system. So the nice thing about OPA is that the language that it gives you is sort of designed for dealing with this complex, deeply nested data. And so, for example, you can refer to sort of deeply nested attributes in the objects. Like in the case of Kubernetes, if you want to enforce a policy over the images, you need to dereference like 4 or 5 or 6 levels of JSON before you actually get to the image name in the object or in the application that you're trying to deploy. OPA also lets you, iterate and do searches over the data and introduce, helper functions, and then wrap all of these things up into rules that ultimately produce decisions that get enforced. And so this is really a great use case for OPA because there's so many different kinds of policies that you might want to actually enforce in your system. And so, as you kind of build out your cluster and as you bring on more and more users, you kind of end up encountering all these different use cases or these different problems that you want to kind of have control over. And so OPA helps you not only codify those policies, but enforce them and then also audit them, right? Like you might want to ask the system, which deployments are in violation of some policy. And so the nature of OPA and the way that you write the policies helps answer those kinds of questions. So that's one particular use case where you can take OPA today and use it. And we've got tutorials on the website that show you how you can kind of get up and running with that. And the second use case I want to talk about is microservice APIs and how you enforce like authorization or access control over who can do what in those APIs. And to kind of motivate this or to explain this further, I'm going to do a little demo. But first, I just want to sort of explain the setup for that demo. So in this demo, we're going to have a sort of a sample application, and it's going to be an application that's composed of a bunch of different microservices. And so at the top level, we have this landing page, which is responsible for composing a bunch of different services and presenting a landing or an employee info page back to the user. And in order to sort of compose that page, it's going to make use of an employee details service that has sort of a database of all the information on the employees. There's going to be a performance review service that's serving relatively sensitive information about employees, and another rating service which is serving performance ratings or employee ratings that are considered sensitive as well. And so the way this works is that when the user requests Bob's profile, they hit the landing page, and then the landing page calls out to the review service and the details service, and they get back data which gets composed and sent back to the client. And so the idea here is that at every sort of hop in this graph, you want to conceptually have OPA queried and ask whether or not that request should be allowed. And so the way you can think of this is that anytime one of these services receives a request, it's actually asking OPA whether or not that request should be allowed. Now, there are different ways that you can actually go about achieving this. In this case, these services are just calling out to OPA over HTTP. And so there's an example on the right that shows what that looks like. So basically, every service is asking OPA whether or not to allow the request. And when they do that, they're providing a bunch of input that describes the incoming request. So like the path that's being accessed, the method that's being used, the source and destination service, the user that's been authenticated, and so on. And then OPA responds or replies with the policy decision, which indicates whether or not the request should be allowed or denied. And so that's just represented here as a Boolean. Now in practice, there are actually different ways that you can go about achieving this. You can take OPA and run it as sort of as a sidecar, or where you basically run it on the same host or in the same pod. Or you can take OPA and embed it as a library if the application is written in Go. Or you can actually take OPA and use it with a service mesh like Linkerd or Istio or Envoy and so on. And so there's different ways of enforcing these policies, but the high-level thing is that the policies that you write are the same regardless of the actual architecture, the enforcement model that you pick. Okay, so the cool thing about this use case is that there's all kinds of different policies that we can actually enforce. And so, for example, what we're going to do is implement 3 different policies. The first of which says it's just sort of like a service graph policy, or one where we try to define the allowed connectivity in the application. And so, here, for example, we want to say that the review service can talk to ratings, but details is not, right? We want to restrict which services can talk to which. The second policy we want to enforce is sort of based on the organization chart, and it's a little bit more organization specific. So here we want to say that managers are allowed to see performance reviews, but the peers of a team member cannot, right? Because those things are sensitive and we don't want them leaking out. And the last thing we want to show actually with this demo is how you can enforce policy decisions that are not just Boolean values. And so here we're going to show how you can restrict access to certain data in the application, or PII, or personally identifying information. And so what we're going to show is how you can say, for example, that only HR is allowed to see the social security number of the employee, right? Not even like the manager is allowed to see that. Okay, so what I have here is the demo application running, and it's actually running on top of Docker Compose. So I have a bunch of Docker containers here. I just want to make sure, is my terminal visible or no?
Not the terminal, just the
okay.
demo.
1 second. Let me make sure that becomes visible. Okay, share my desktop. Okay, so there's the sample application on the left.
Okay, that's better. Yeah.
That's better. Okay, just 1 sec. Let me resize everything here. Just going to close the chat for a minute. If someone asks a question, just let me know. Okay, so I have this sample application running. It's a little bit hard to read, but it's running. There's a bunch of different containers here that represent the different microservices in the application. And what I have is a policy right now that's actually being enforced. So all these services are calling out to open. Let me make this a bit bigger. Okay, so we have this policy that's being enforced because all the services are asking OPA for policy decisions. And so basically you can read this policy as, right now, allow is by default going to be false. However, if the service graph policy allows it, then the allow will be true. And now, so in order to understand actually how what this policy is doing, we need to look at a different policy here, which, there we go, is in the service graph file. And so this policy is similar. It's got a default, and then it's got these allow rules. But what's interesting here is that the policy is basically interpreting this data structure above. So in this case, we've sort of hard-coded the service graph in here, but this could equally just be data that's pushed into OPA. And so what this service graph says is that, for example, the landing page is allowed to talk to details, and reviews is allowed to talk to ratings. Now, the thing is that right now, allow is actually set to true. And so basically, everything's just being allowed. And so if we flip this to false and we save it, the policy is going to update automatically. And now we can see that the performance reviews are not being served anymore. And the reason for that is because in the service graph, we don't allow landing page to talk to the reviews service. And so if I go and I update the review, add reviews to the service graph so that landing page can talk to reviews, and we refresh the page, we'll see that the reviews show up. So what's happening in this policy is basically it's checking whether or not the incoming request should be allowed, and it makes that decision by looking up in the service graph what are the allowed targets for this input service. And so we grab the allowed targets, and then we search to see if the target service is in that list. And if it is, then the request is allowed. Otherwise, the default gets applied and the request gets denied. Okay, so this is a relatively simple policy, but it's nice because it sort of illustrates that you can change the policy, and the change is reflected immediately in OPA, right? It's basically just watching this file for changes, and whenever it sees a change, it reloads it automatically. And so if we add back the details service, the details are displayed again. So this is cool, but we want to also sort of enforce more kind of organization-specific or interesting policies. And so what I'm going to do is imagine that we've been given this other policy by somebody else in the organization. And this policy restricts whether or not you can see sensitive information about the employee. And so this policy is very similar to the last one. We have this data that describes the sort of org chart. And this could be also loaded in this JSON or contained in a JOT token. But here we've just put it in the policy because it makes it easier to change. And so what the policy is doing is interpreting that data structure and deciding whether or not to allow the request. Now, in the interest of time, I'm not going to go through it in too much detail, but basically it's just checking whether or not the incoming user is requesting their own performance reviews or they are a manager of the person who they're requesting. And so in order to actually have this policy enforced, we need to hook it up to sort of the entry point of the policy. And so what I'm going to do is go and add that here. And now this policy basically reads, by default, allow is false. However, if the service graph policy allows it and the organization chart policy allows it, then allow will be true and the request will be accepted. And so now that I've added this, I can refresh the page. And when I do so, we see that the performance reviews don't show up. And the reason for that is that I'm not actually logged into the application right now. So we can go through and sort of test the different combinations here. So if I log in as Bob, for example, we see that he's able to see his own performance reviews, which is what we want. But if I log in as, say, Alice, who's his team member, she's not allowed to see them, right? They don't show up. But just to work through this, so if I go as Janet, who's Bob's manager in the hierarchy, right? Bob here reports to Janet, then she's allowed to see them. Okay, so that's just sort of a simple example of how you can kind of enforce these organization-specific policies using OPA. And the last thing I want to do is just go through that personally identifying information example. And so what I have here is basically a rule called PII. And what it's doing is it's producing this array with a string social security number in it based on some constraints. And so the idea here is that the details service is actually calling out to OPA twice. It's calling out once to get the allow decision, and then it's calling out again to get the sort of the sensitive fields or the personally identifying fields that it should hide depending on who's asking for them. And so now that I've uncommented this, if we refresh the page, we see that the social security number value is actually blanked out. And the reason for that is that we're signed in as Janet, who's just Bob's manager. She's not part of HR, and it's not Bob, so the social security number shouldn't be displayed. And so if I sign out, we see that everything's sort of hidden. But if I sign back in as Bob, he's allowed to see his social security number. And if I sign in as Ken, who's from HR, we should be able to see it. And so let's just do that. So here we go. Right, so Ken's able to see the social security number, and he's also able to see all the performance reviews. So this is just an example of how you can use OPA to enforce policy decisions that are not just Boolean values, right? We've defined this policy decision that here is actually an array containing potentially one or more or zero more strings, right? And so the employee detail service knows how to interpret this and use it to restrict which fields are sent back to the client. Okay, so that's it for the demo. And I hope that made sense to everybody. So I just want to say thank you to Vasu and Adele for organizing all of this. If you have questions about OPA, please join the Slack organization that we have. We can answer questions. There's other people in the community that can help answer questions. And we also have this is all open source. It's on GitHub. So please go check out the GitHub repo, star it if you haven't already. And there's a list of presentations and slides at the bottom. So if you want the slides from this talk, you can actually go and look there. There's a slide deck that's quite similar. And there are some other presentations that we've done with groups like Istio and Netflix. So with that, I'll hand it back to Vasu, and I'm happy to take questions now if there are any. Otherwise, yeah, thank you very much.
So, well, thank you, Torin, very much. So one of the things I just noticed is very difficult to convey is the clapping of the crowd, right? For this fantastic speed, indeed. Guys on the phone, guys everywhere on the remote, please, if you have questions, this is your chance. Speak up.
Torin, I have a question. So you mentioned at the end that the service would understand, for example, if you mentioned in the policy a social security number, does this mean that the service need to understand how policies work or interpreted in OPA, or is it kind of like hidden in a way so that it's service agnostic?
That's a good question. Yeah. So it's let me just bring up that policy. So it's kind of the idea with OPA is that the application or the service that's integrating with OPA only needs to know the name of the decision. In this case, it would be example/PII, and then how to interpret that decision, which is just JSON data, right? So in the allow case, it's asking for the allow decision, and it gets back true or false. And in the PII case, it's asking for the PII decision, and it gets back an array of strings. So it just needs to know how to interpret that data. It doesn't need to know how to interpret anything in the policy, okay? So this is like the implementation, and the rule, or the head of the rule, as we say, is sort of like the interface for the decision. It's the thing that the application has to understand. And so in this case, it needs to know how to interpret. It might need to know how to interpret SSN, or it might not. Like if this is something that you're just filtering out of a response, then you don't necessarily need to understand the semantics of social security number. You just need to know that that field should not be displayed or whatever, depending on the user. Does that make sense?
Yep. Thanks for answering.
Great.
So Adele, you just asked my question. Thanks. I might have a question which is not entirely related to the project itself. all of the OPA source code and everything is developed open source. Can you tell us the relationship about the startup you also have founded around it? Is there a commercial product? Do you sell services, consultancy, or how? Can you tell a little bit
absolutely,
about that?
Yeah, so there's a startup behind it called Stira, but so OPA is totally open source. It's been open source since day one. It's meant to be this kind of community project, and the reason for that is just that this sort of thing benefits from being in the open because it's inherently related to security, and you don't want to have security kind of wrapped up in a bunch of proprietary software. So OPA is totally open source. The startup Stira behind it, we provide services that help you kind of manage OPA and policies in general. So if you can imagine, if you have, thousands of OPAs running around, you need some way to distribute policy to them. And, you can build that yourself if you want to, but you can also leverage our services to help with that. So you can think of the startup as sort of a management layer, at least.
Okay. That makes sense because in essence, you want to optimize the policies that you want to send to all of these various different daemons or libraries.
Yeah.
You don't want to have large blobs sending it to every one of them, right? So that's essentially the management framework which you're working on. Yeah.
Yep. So that's a separate thing. It runs as a service. If anybody's interested in chatting more about that, I'd be happy to set up meetings for that.
Mm-hmm. Perfect. Any other question in the round?
Yeah, Torin, here's Martin speaking. First of all, thanks for the presentation. I have a question. Is there an integration available with Active Directory services to provide, for example, things like roles?
We don't have an open source implementation of an Active Directory integration. It's actually relatively easy to push data into OPA. It's basically just a single HTTP put call. So if somebody in the community wanted to build an Active Directory integration that loaded data out of AD and into OPA, we'd be happy to include it in our contributions repo, but it doesn't exist today. But it's something that we've heard a lot about and sort of on the roadmap, so to speak.
Okay, thanks.
Okay, so if there are no other questions, I'm happy to hand it back to Nico or whoever's next.
Okay, well, indeed. Thank you, Torin. Again, a virtual crowd clap from my side. This is fantastic. It also, instead of me reading all through the nitty-gritty details of the GitHub project, this was a fantastic introduction for myself. I really thank you for that.
Okay, yeah, so thanks everybody. Check out the repo, start it, and feel free to ask questions on Slack.